Okay, in this video, we're going to go through the Unit 8 vocabulary. So we've got a quick color, I say quick, I like to talk a lot, so it might not be super fast. Sorry, I just recorded this video actually, but my computer was about to die, so it stopped the recording and I didn't realize. So it went on and on and on, finished the video, and now I'm all sidetracked, so I'm gonna take a second and think about what I need to do again. Alright, got it. So if you were in my class, my math class from 2021 to 2022, I mislabeled the pages. Oops. I should say page 28. We started over at the second semester, so that is page 28 in your binders, not page 128. So sorry about that. Alright, now first, we're going to review kind of what parallel lines means. I haven't taught that this year, but you have seen parallel lines in the past. We kind of talked about it with slope. Parallel lines are just any two lines. You guys all are saying it's any two or more lines, so 2 plus lines that never, and you guys like to say that never cross or meet or touch, right? Another way to think about parallel lines is that they are always the same distance apart. We did talk about this with slope a little bit because the lines have, they change together, right? So if I had them like this, then their rise over run, they change at the same rate. So they go up the same amount and over the same amount. So their slope is also the same. So three ways to think about that. Lines that never cross, lines with the same slope, lines that are always the same distance apart. So there's a running math joke that it's a shame parallel lines will never meet because they have so much in common, which is kind of funny if you think about it. Alright, so I'm going to just label the parallel lines that I have. That would be this top horizontal line and the bottom horizontal line are the two parallel lines in the diagram here. Okay. We are specifically concerned about angles in this unit, so it's really weird to talk about lines right now. But if I have some lines, and then I throw a line over them that crosses through them, that creates a bunch of angles for me to talk about. So the line that crosses over the parallel lines is actually really important for us. It is an important line, an important thing in math, so it has its own name. We call it a transversal. So transversal is one that I have colored in yellow. And we know that transversal, just from looking at the picture, I asked you guys in class, and most of you are saying the yellow line crosses the gray lines, or crosses the parallel lines. A transversal is just some line. Often we call that line T, because transversal starts with T. A line, T, that crosses over parallel lines. So I'll go ahead and also label the transversal as T. Alright. Now because the transversal across the parallel lines, the line across the parallel lines creates all these little angles, and there's so many of them. We want to name them just so we can refer to them as something. So I'm not pointing this one here and that one there. It's just a better way to talk about them. We'll have angle 1, angle 2, angle 3, angle 4. So I'm going from from left to right and top to bottom. So we've got 1, 2, 3, 4, angle 5, 6, 7, 8. All right, the next thing I'd like to do is I think we're going to have to end up talking about angles between the two parallel lines. So here's the parallel lines. Between would be on the inside of them. So 3, 4, 5, and 6, which can sometimes be difficult to see. So what we're going to do is if we see a diagram like this, I want you guys to connect the two parallel lines off to the side. make a little rectangle out of your parallel lines. Now what that's done is created a box. So we have an inside of the box and an outside of the box. We call the inside of the box the interior. Interior just means inside. Think about an interior designer. They design the inside of our houses. Now logically thinking, we'd say then the outside of the box is outerior. The outerior is not an English word, I suppose. So we actually say exterior. Exterior. I didn't mean for the T to be capital. Think like EXT mean almost is almost the word exit. So we're exiting the building or going outside. Interior inside, exterior outside. And that came from the box. What the transversal did not only was cut up the two parallel lines into 8 different angles, it also split up our it also split the angles up to a left side and a right side. So we can see the angles 1, 3, 5, and 7 are on the left, 2, 4, 6, 8 are on the right. I'm going to call this the right side of the transversal, and this will be the left side. Right side, left side. Okay. All right. I'm going to start out by coloring in these boxes. Color is going to be important because these boxes will tell us which angles we're talking about using the color. So I'm going to talk about corresponding as the pink angles in my diagram. Now corresponding means matching or in the same position or in the same spot. So let's just start out with angle number 1. I'll color in angle number 1. Angle number 1 is from the top line, right? And angle number 1 is outside of the box, Number 1 is on top of the parallel line and on the left side of the transversal. So when I look down at the other parallel line, I want the angle that is in the matching or same spot. On top of the parallel line and on the left side of the transversal is angle 5. You can think about, in class, our desks are split into little groups of 4, right? Your little math families. Think about where you sit in class, what math family you're in, where your desk is located in that. You're either one of the front desks or one of the back desks, on the left or on the right. Now think about if you were sitting in another math family, who would be in your seat? So your seat and their seat, since you guys are in the same spot in different math families, you guys would be corresponding. So angle 1 and angle 5 are corresponding because they're both on the top of the parallel line and they're on the left side of the transversal. So left of T. All right. Now, the 1 and 5 are not the only corresponding angles we have in the diagram. It's just the ones I decided to color. If I talked about angle 4, angle 4 from the top line is on the bottom of the parallel line and the right side of the transversal. Matching that from the other parallel line, bottom and on the right, is angle 8. So 4 and 8 are corresponding. You can see 2 and 6 are corresponding, 3 and 7 are corresponding. The next word we're going to take a closer look at, is same side exterior. Same side exterior. When we say the same side, we're going to specifically refer to the same side of the transversal. So this is the same side of the transversal. I'm going to call that T because I don't want to write out the transversal. Same side of T. And when we say exterior, we just mean simply outside of the parallel lines or outside of the box. So let's color in angle 2. And now let's find, using the definition, same side of the transversal, exterior, outside. Using the definition, let's find the angle that is same side exterior with angle 2. So same side, now angle 2 came from the top, so the same side exterior angle would be from the bottom parallel line, which means your options are 5, 6, 7, and 8. We need something on the same side of the transversal. Well, 2 was on the right. On the right, we have 6 and 8. So we can't use 5 and 7. So we've got 6 and 8. And we need the option that's on the outside, the exterior. 6 is inside of the box. 8 is outside of the box. So the same side, right, exterior, outside, angle with 2 is 8. Okay. So we can say that angle 2 and angle 8 are same side exterior because they were both on the right side. The right side and on the outside. They're right and out. So same side exterior angles only work with outside angles anyways. 2 and 8 are same side exterior. Another outside angle I could look at is angle 7. Now angle 7 is on the left outside. The other line has outside angles 1 and 2. On the left is 1. So angles 1 and 7 are also same side exterior outside angles. All right. I'm looking now at alternate exterior. Alternate exterior. Alternate, we talked about up and down, left and right, going back and forth between the two because they're opposites. So alternate meant opposite. And again, when we talked about same side, we said same side in relation to the transversal, so either left or right of the transversal. Or if this diagram was flipped and the transversal was this way and our parallel lines went straight up and down, then it would be top and bottom for your transversal sides, right? Okay, so we need the opposite side of T. When I say alternate, it just means opposite. Okay, and exterior means outside still. Still working with outside angles. Let's go ahead and take a look at angle 8. And using the definition of alternate exterior, we're going to find an alternate exterior for angle 8. Alternate meaning opposite of the transversal. So angle 8's on the bottom parallel line, so its alternate exterior angle will come from the top parallel line, angles 1, 2, 3, and 4. Opposite of the transversal, well, 8 is on the right, so one of the angles we need has to be on the left. The angle we need is on the left. This is alternate exterior, meaning outside of the box. Well, 3 is on the inside of the box, so 1 is the alternate opposite side of the transversal, exterior outside angle. So alternate exterior with 8 is 1. Again, this is not the only pair of alternate exterior angles. 2 is also an exterior angle. 2 is on the right. 2 is also an exterior angle. 2 is on the right. So we need something from the left. That would be angle 5 or 7. 5 is inside the box, 7 is outside. So angle 2 and 7 are also a pair of alternate exterior angles. We just colored in angles 1 and 8. We named them alternate exterior because 1 was on the left, 1 was on the right, 8 was on the right, I guess, and they were outside of the box. Okay, now let's look at vertical angles. Vertical angles are kind of counterintuitive because you guys already know the definition of vertical means up and down. So if you'll bear with me for a moment, I'm going to draw an X off to the side. If I'm talking about the space here on the top side of the X. Vertical to it would be right underneath the bottom side of the X. Now if I talk about the part that's on the left side of the X, vertical to it is still on the left side of the X, unless you turned your paper, you rotated your paper. Now vertical up and down shows us to be on the top there. If you turn your paper back to normal, that vertical line is left and right, because when you turn it, left and right becomes up and down. So when we say vertical, yes, it is up and down, but you might have to turn your paper in order to see that very easily. So when we're talking with angles, it's easier to define vertical as across instead of vertical, up and down. So we're going to say that I'm going to leave some room here, and you'll see why in just a second. So we need across, and I think this diagram tends to help 8th grade students see vertical angles a little bit easier. So we're going to say across in an X, across in the X pattern. Okay, and it's important that you realize vertical angles only use one parallel line. Up until now, we've been finding pairs of angles, and in the pair of angle, angle pairs, sorry, one angle came from the top parallel line and one came from the bottom. Because these have to create the X pattern, that's only coming from one set of parallel lines, from one parallel line with the transversal. Okay, so let's find the vertical angle for angle 7. Okay. I'm just picking that one because it was an open space to color. There's no math behind me picking it, no logic, no definitions behind me picking 7. Okay. So vertical across from 7 in the X pattern. If I cover that top, you can see the X pattern a little bit better. If I turn it sideways, you can see it even better. Now vertically across from the vertically across from the 7, I said vertically, I mean across from the 7 in an X pattern is 6. That doesn't look vertical. Again, if you turn your paper, now 7's on the top and 6 is on the bottom, and that's very clear that those are vertical. 7 and 6 are across from each other in an X pattern. If you rotate your paper, you can see the vertical portion of that. Okay, so we picked 7 and 6 because they are across from each other in the X pattern. We have other sets of vertical angles in the diagram. I just picked to color 7 and 6. If we picked 3, then the X pattern is between 1, 2, 3, and 4. Vertically across in the X of 3 is 2. Vertically across the X is also 1 and 4. We've got 5 and 8 are vertically across an X, and 7 and 6 are across in an X. All right, looking at same side interior angles, I'm going to use red now. Okay. Same side interior, similar to when we were talking about the exterior types of angles, same side exterior, alternate exterior. Same side interior is the same side part refers to the same side of the transversal. So this is same side of the transversal. If I'm talking about left, the same side interior angle will also be on the left. If I have a right angle, then the same side interior match will also be on the right. Interior still means inside. So oh, that's not how you spell inside. Inside. That just looks wrong now. I'm sure it's spelled right. It's got to be spelled right. Okay, so same side interior angle. Let's go ahead and find that for angle 5. I'm picking that because it's something on the inside. Obviously, I need an angle from the inside. I think that's clear because of the word interior. I'm just picking it because there's a spot to color. All right, so we want same side interior for angle 5. Now, this isn't vertical, so I don't have to be on the same spot of the X. I don't have to make an X because this is the same side. So I'm not making the X, which means I can use both parallel lines again. Now we are talking about angle 5, which was the bottom parallel line. So its same side interior will come from the top parallel line. That means my options are 1, 2, 3, or 4. I need something interior because of this word. So inside the box, interior. That leaves me only 3 or 4. And I also need same side of the transversal. Well, 5 was on the left, so between 3 and 4, 3 is on the left, meaning that 3 and 5 are same side interior angles. Okay. And just like above, that's not the only set of same side interior angles, right? I have another pair of interior angles, 4 and 6, right? I have 2 other interior angles. Well, 4 and 6 are inside the box. On the right side of the transversal, 4 and 6 are also same side interior angles. I simply picked 3 and 5 because it was something to color. We said angle 3 and angle 5 are same side interior because they were both on the left and inside of the box. Now looking for alternate exterior. I'm going to use a brown marker this time. Alternate exterior angles. Or sorry, interior. I can't read. Alternate interior angles. Alternate still means opposite and opposite in relation to the transversal. So alternate is going to tell me opposite of the transversal. And interior still means inside. Alright, so if we looked at angle 6. Let's look at angle 6. That's hard to see. So I'm looking at angle 6 right here. I need something that is opposite of angle 6, but on the inside of the box. So angle 6 comes from the bottom parallel line. So its alternate interior is going to come from the top parallel line. So the angle options I have now, just from looking at the 2 separate lines, are 1, 2, 3, and 4. 6 was on the right side. So because this says opposite, I need something from the left side. That leaves 1 and 3. Because this says interior, I know I need the angle that's on the inside of the box. So since 1 is on the outside and 3 is on the inside, then 3 and 6 are alternate interior angles. Okay. So we've got angle 3 and angle 6. They're on separate sides of the transversal, but still inside the box. Similar to that, 4 is on the right, and on the other parallel line, 5 is on the left. So 4 and 5 are alternate interior angles, since they're opposite sides of the transversal and inside of the box. Again, I only picked 6 and 3 to color, so I had something to color with. Angle 6 and angle 3 are alternate interior angles because angle 3 was on the left, angle 6 was on the right, and they were inside of the box. Alright, last, we've got adjacent. Okay, adjacent means besides. I'm going to underline side, and I'm going to say that adjacent angles share a side. I'm going to use that very loosely. That word side, I mean. When I say side, I just mean whatever portion of the line helps outline the angle. So let's look at angle 4. Now the stuff that outlines angle 4 is this part of the horizontal top parallel line and this part of the transversal. Now adjacent angles are sharing a side. The horizontal thing I have outlined in green for angle 4 that horizontal portion shares angle 2. So angle 4 and angle 2 are adjacent. I'm going to write that word adjacent because there's not a spot to color there. Oh, there is a spot to color there. Boom, done. Okay, but you'll notice angle 4 didn't have one side outlining it. It had another portion of another line outlining it, and that was the bottom part of the transversal here, which helps outline angle 3 somehow. So angle 4 is also adjacent with angle 3. So when I'm looking for angles that are adjacent to something, if I say I need an angle adjacent to 7, then there are two options because there are two different sides that help outline 7. So adjacent to 7 you can see is 5 and 8. Now because they have to share a side like that, adjacent is the only other option, the only other vocabulary word that is going to come from one set of parallel lines. From one of the parallel lines, not one set. All right, a couple more things to talk about. We defined something that was on the same side of the transversal, just on the inside or the outside, as same side exterior or same side interior. Make a note that same side can also be referred to as co. So if I said same side interior, instead of same side, I could say co to get co-interior. So this would mean same side interior, even though it's spelled co-interior. Just like if I said same side exterior, instead of saying same side, I can say co-exterior. Co-interior and co-exterior is another way to say same side interior, same side exterior. The last thing I want to talk about should go fairly quickly. Just 3 more vocabulary words. This talks about specifically the measurement between angle relationships. So if two angles are congruent, that means that their measures are equal. If I say angle 1 is congruent to angle 5, and I then told you angle 1 was maybe, let's go 106 degrees, then angle 5 would also be 106 degrees. All right, so you can see off to the side we've got equal signs and equals 180. So all this is going to show me is that congruent angles have equal measures. So anywhere you see an equal sign means that that vocabulary word, that relationship, means the two angles are equal. You can see angle 1 and angle 5. If they're in the matching or same spot, then they have the same measure. The equal sign means they're congruent. So alternate exterior angles are also congruent. Vertical angles are also congruent. Alternate interior angles are congruent. So if I've got matching spot, same measure, alternate sides, somehow alternate in or out, and then vertical, so across. Those will give me pairs of angles that have the same exact measure. Now the other one that's important specific to this kind of diagram here is the word supplementary, and that's where the two measures, the measures of the two angles, measures to equal 180 degrees. It's a bit of a far-fetched for me, but I know it's helped some people, so I'll show you guys on the video real quick. Some people take the S and they put a slash through it, so now it kind of looks like a really weird drawn 8, which helps them remember 180 for some reason. So now looking at what kind of angle pairs will yield 180 degrees. And I think the best way to show you this is adjacent angles. Adjacent angles are supplementary. Hopefully in class so far we have already done the activity where we have a little piece of triangular paper and we cut off all the corners, and then we put the angles from the triangle together to create a straight line. And then if we take, so 180 degrees makes a straight line, and then if we take two of those triangles and cut them up, then the angles all make a circle. So that's 360 degrees for a circle. Anyways, so adjacent angles are beside each other, like 4 and 2. You'll notice angle 4 and 2 create a straight line on the transversal. You'll notice 4 was also adjacent to 3, and 4 and 3 make the horizontal straight line. So adjacent angles are supplementary because they make a straight line. So if I had the angle 4, since it's vertical with angle 1, I know it's also 106 degrees. Then angle 4, 106 degrees, is going to make 180 degrees with angle 3. So the number that makes 180 with 106 is 74. So 106 and 74, if you add them together, you'd get 180 because those angles are supplementary. Other supplementary angles, if you have anything that's same side. If it's same side, then they're 180 degrees. And if they're adjacent, 180 degrees. Same side, adjacent, 180. Corresponding, congruent. Vertical across, congruent. And alternate, congruent. That is all of the notes I have for this. I know this is a very lengthy vocabulary session, but it is also really visual, so we had to take it really slowly and talk about the parts of each different word. If the vocabulary part is making you scared or you're struggling to understand any of the vocabulary, please come find me so we can set up a time together to review that, or shoot me a Schoology message or an email. My contact information is all over Schoology for you.